So we're in section 9.4. So a couple of important things to start. Quadratic equation. We have ax squared plus bx plus c equals 0. Now when we have a quadratic equation, when we have an x squared in our equation, we always want to start with our equation equaling 0. That's a very common mistake that students make with quadratic equations, is forgetting that we want our equation to equal 0. So our first step is to get them equal to 0. Now we talked about solving by square roots the other day. We can solve by square roots if b equals 0. So then our equation looks like ax squared plus c equals 0. When our equation looks like this, ax squared plus c, that's when we can solve by square roots, when we don't have this bx part. But we start with our equation equaling 0, and then we get x squared by itself. Today we're going to solve quadratics where b is not 0. So before, the only way we had to solve those was by graphing. Sometimes, usually, when we graph those, the graphs are not, the vertex is not necessarily in a nice place. They don't necessarily cross the x-axis in a nice place. So factoring is going to be an easier way for us to solve these. An important tool that we're going to use for solving these is called the zero product property. The zero product property tells us that if a times b equals 0, we're multiplying two numbers together and we get 0. The only way that is possible is if a equals 0 or b equals 0. One or the other of those numbers has to be 0 in order for us to get 0 when we multiply them together. That's the only way we get 0 when we multiply, is if one number is 0. So we have two possibilities here. Either a can be 0 or b can be 0. There's no other way when we multiply numbers to get 0. So this is kind of one of our key things when we solve by factoring. When we solve by factoring, we always end up using the zero product property. So for example, if we factored some quadratic equation and we ended up with 2x plus 3 times x minus 1, and that's equal to 0. So we've done our work, we've done our cross in our box, or we did our slip and slide, and we get this as our factors. The zero product property tells us the only way that multiplying these two together gives me 0 is if 2x plus 3 equals 0 or x minus 1 equals 0. And now I want, and we're going to say the problem says find x. Well, we're going to find x for each one of these. I'm going to subtract 3. So I get 2x equals negative 3. divide by 2, and x equals negative 3 over 2. We could divide and say that's 1.5 if we wanted. Negative 3 halves is okay. Here I'm going to add 1. I'm going to bring this all the way down. I get or x equals 1. So I get two answers. I get one answer for each set of parentheses. X equals negative 3 halves. That makes this equal to 0. Or x equals 1. That makes this equal to 0. Usually, when we solve a quadratic equation, we get two answers. And if we think about the graph of a parabola, if the vertex is anywhere not on the x-axis, it's going to go, if it goes through the x-axis because it's a U-shape, going up or going down, it's going to go through the x-axis twice. So that's why we end up with two answers. All right, so we get problems on your homework that say, use the zero product property to solve for x, and you'll have something like this. What that means is, set this one equal to 0, set that one equal to 0, and get x for each set of parentheses. All right, so let's talk about solving a quadratic equation. That's what we're ultimately interested in doing. We want to solve x squared minus x minus 12 equal to 0. So solve means figure out what x is. I have my equation equal to 0. That's good. To solve this, I'm going to factor this quadratic. A is positive 1, B is negative 1, and C is negative 12. So just a reminder about factoring. If I set up my cross, I need to find my factors. We always put A times C here. A times C is 1 times negative 12, which is negative 12. So that goes here. We want two numbers that multiply to negative 12 and add to B, which is negative 1. So we need two numbers that multiply to negative 12, add to negative 1. I'm going to think to myself here, well, to get two numbers to multiply to a negative number, one of those numbers is going to have to be positive, and one is going to be negative. So my factors of 12 that add to negative 1 are going to be negative 4 and positive 3. Negative 4 times positive 3 is negative 12, and negative 4 plus 3 is negative 1. Now, since A is 1 here, I don't have to use the box. I can go straight to my parentheses, and I get x minus 4 times x plus 3 equals 0. And we're not done yet. This is part of the problem. Now we need to find x. Well, this tells me that x minus 4 equals 0, or x plus 3 equals 0. I'm splitting this into two equations. Here I add 4, x equals 4, or here I subtract 3, and I get x equals negative 3. So my two answers are x equals 4 or x equals negative 3. Usually when I solve a quadratic equation, I get two solutions. All right, questions there. Let's look at another one. We're still solving. Solve 3x squared plus 13x equals -4. So I see this x squared, and the first thing that I think is, well, for my equation, I need it to equal 0. Well, here we have a -4. So I'm going to add 4 to both sides. And I get 3x squared plus 13x plus 4 equals 0. Now I have my quadratic equation the way I want it. A is 3, B is 13, C is 4, A times C is 12. So I'm going to set up my cross. Our numbers that we pick are going to multiply to 12 and add to 13. And I'll do this one both ways. I'll do this one with the box and with slip and slide, just to remind us about those, how we do those things. So I need to pick two numbers that multiply to 12 and add to 13. Well, 1 times 12 is 12, and 1 plus 13 is 13. So we're going to get 1 and 12. And if you're not sure, you can always just start listing the factors of 12. 12 is 1 times 2, 2 times 6, 3 times 4, etc. And look for the ones that work the way you want it to. All right, so we have 3x squared. Here we have 4. We have a factor and x. A factor and x, 1 times x. Now we take our greatest common factors out. The biggest number that goes into 1 and 4 is 1. Biggest number that goes into both 3 and 12 is 3. The smallest x that's in here is 1x. Biggest number that goes into 3 and 1, 1. Smallest x here is x. Biggest number that goes into 4 and 12 is 4. We don't have x here, so we can't pull out an x. So this tells me 3x plus 1 times this 1x, I'm just going to write as x plus 4 equals 0. So I factored this. We need to find x. Before we find x here, I'm going to show how to factor this with slip and slide, just to remind us, for those of us that like slip and slide. Slip and slide. So I'm going to say 3x squared plus 13x plus 4 equals 0. We're going to slip this 3 over here and multiply. So I get x squared plus 13x plus 12. And I'm just thinking of factoring this. I don't need to worry about it equaling 0, because I know I'm going to set it equal to 0. We would need our cross. We need to pick out our factors here, just like we did here. So we know that is x plus 1 and x plus 12 from here. But we multiplied by 3, so we need to divide by 3. This we can't reduce, so the 3 slides over. This does reduce, so we can write this as 3x plus 1 times 12 divided by 3 is 4. So I end up in the same place here. Well, now I need to find x. This tells me that 3x plus 1 equals 0, or x plus 4 equals 0. So I'm going to solve each of these. 3x equals -1. Divide by 3. X equals -1/3. Here I'm going to subtract 4. I'm going to bring this all the way down. Or x equals -4. two solutions are x equals negative 1/3 or x equals negative 4. And this one, if we try to graph this one, because of the way these numbers worked out, this one would be kind of not a nice graph, I don't think. All right, questions? Okay, sometimes we don't have to use the cross and the box to do our factoring. Sometimes we can just use a greatest common factor. So let's look at one of those examples. 4x squared minus 4x equals 0. So here I have a c equals 0. So there's a, there's b, c equals 0. When I have c equals 0, that tells me that I'm probably going to factor just by finding a greatest common factor. So our greatest common factor here, well, 4 is the biggest number that goes into both 4 and 4. And the smallest x that both of these have is x. So my greatest common factor is 4x. Now if I pull that out, I get 4x times, when I pull a 4 out of here, I just have a 1, and I pull one of these x's out, I'm left with 1x. And here, when I pull a 4x out of minus 4x, I end up with negative 1. And you can always check your work here by distributing. 4x times x is 4x squared. 4x times negative 1 is negative 4x. Now I have two things that are multiplied together that give me 0. So this says 4x equals 0, or x minus 1 equals 0. Divide by 4, and I get x equals 0. Or I add 1 here, x equals 1. And those are my two solutions. X equals 0 or x equals 1. Now we should always look for a greatest common factor, but when c equals 0, we have to solve this by finding the greatest common factor. We have to factor this by finding the greatest common factor when c is 0. All right, questions there? Okay. One last example. Our favorite kind of, well, I was going to say our favorite, but I'll say the kind of problem from chapter 8 that always at least got a reaction from students. I'm going to say this is 22 feet, and this is 12 feet, and this is x, and that's x. And the problem says the total area is 504 feet squared. We want to find x. All right, so here's what I'm going to do. If this is x, this width is also x. The strip is the same width on all sides. And that is x. So this whole big side here is 22 plus x plus x. So I have two x's. So I'm going to say that's 2x plus 22. This whole side, well, there's one x, there's another x, so there's two x's, plus 12. So the area of the big rectangle is 2x plus 12 times 2x plus 22, and that equals, the problem tells us, 504. So we're going to multiply these together. So I'm going to FOIL this. First, 2x times 2x, 4x squared. Outside, 2x times 22 is 44x. Inside, 2x times 12 is 24x. And last, 12 times 22 is 264. If I add these together, I get 68x. So this becomes 4x squared plus 68x plus 264 equals 504. Well, this is a quadratic equation. I know I want 0 here. I want it to equal 0. So to make that happen, I'm going to subtract 504. When I do that, I get 4x squared plus 68x. 264 minus 504 is negative 240 equals 0. Now we should check for a greatest common factor. 4 does go into 4, 68, and 240. So our GCF is 4. So I'm going to take that out. 68 divided by 4 is 17. And negative 240 divided by 4 is negative 60. And now I want to factor this quadratic. So I'm going to make my cross over here. There's A, there's B, and there's C. A times C is negative 60. So that goes here. We want to multiply. We're going to add to 17. So we need factors of negative 60. So factors of 60 that add to 17. So factors of 60. So I'm going to do those here. 60 is 1 times 60. Well, that's not going to get us to 17. 2 times 30. Well, that's not going to get us to 17. 3 times 20. Oh, that could get us to 17. 20 minus 3 is 17. And we know this has to be a positive and a negative. That's the only way we're going to get a negative number when we multiply. So this has to be positive 20 and a negative 3. So what I end up with here is 4 times x plus 20 times x minus 3 equals 0. Well, now I have 3 things multiplied together to give me 0. Well, 4 is not equal to 0, right? So we can't have that. X plus 20, thank you, equals 0, or x equals negative 3. So I subtract 20, and I get x equals negative 20. Sorry, x minus 3 equals 0. Add 3, and I get x equals 3. Can we have a negative 20 for a width here? No. So I'm going to throw that one out. That one doesn't give us an answer that makes sense in terms of our problem. We can't have a width of something be negative 20, so we say x equals 3 is our solution. The width of that bit around the center rectangle is 3 feet. This is a nice problem. We have this nice rectangle here. We have to FOIL. We have to get a quadratic. We have to find the greatest common factor. Then we have to factor. This is nice because the only thing that would, if we had a graph here also, we'd have everything that we've done in chapter 9 all together in one problem. That'd be pretty exciting. All right, questions? Okay. Our homework. We're in section 9.4, page 571. Eight through 38 even, 27, 35, and 37.